So what I'd like to do now is provide you a very boring video explaining how to solve and graph absolute value inequalities. I suggest you go back and find the video on solving absolute value equations to see an explanation of what an absolute value is and how it comes to have two solutions. This one, I'm just going to show you how to take an inequality with an absolute value in it, solve it, and show its solution on a graph. Step one, isolate the absolute value part of the inequality. This one's already isolated. The absolute value part is the only thing on the left. The number is the only thing on the right. So what you do now is you take that inequality, the absolute value thing, write the absolute value thing without the bars, and write it with the same operator and the same result. But you're also going to write a second version of this inequality that's also what's inside the absolute value bars. It's going to have a negative result, and it's going to flip the operator. Now we have two inequalities, and we're going to solve each of them separately. I'm going to add 3 to both sides here to get 2x is greater than or equal to 8. And then I'm going to divide both sides by 2 to find that x is greater than or equal to 4. Now to the other one. I'm going to add 3 to the others to each side and find that 2x is less than or equal to negative 2. And I'm going to divide both sides by 2. Remember, if you divided by a negative, you'd have to flip this. We don't have to in this case. So x is less than or equal to negative 1. These are the 2 points that show up on the graph. X is greater than or equal to 4. Greater than or equal to means solid dot, and greater than means we shade this direction. X is also less than or equal to negative 1, so we shade this, and since it's less than, we go this direction. This result turned out to be what's called disjoint. It's an or. The solution is either here or here, and anything inside the purple area would make this inequality happy. Let's try it again. This one's a little bit simpler looking, right? We're going to have x plus 5, because that's what's in the absolute value section, and it's isolated, so we're ready to go here. And it'll be greater than or equal to 2. We'll also have x plus 5, only it'll be less than or equal to negative 2. Change the sign and flip the operator. Then solve them both. Subtract 5 from both sides. X is greater than or equal to negative 3. Subtract 5 from both sides. X is less than or equal to negative 7. Now, this time I don't have numbers on the graph, so find some. Here's negative 7. Here's negative 3. They're the only things I care about. X is greater than negative 3, so we're going to go this way. And it's greater than or equal to, so solid dot. X is less than or equal to negative 7, so this way. We're solved. Anything out here or out here satisfies this inequality. Are you ready to go for the big smash? Then let's go. Step 1, which we didn't have to do before, is isolate the absolute value section of the inequality. So let's see, that times 9's there, but this plus 10 is kind of a problem first. So I'm going to subtract 10 from both sides. And I'll go down here where I have some more room. So 9 times the absolute value quantity x plus 8, that canceled out, is less than or equal to, looks like, 45. Now I can't distribute the 9 into the absolute value thing because the 9's not being absolute valued. So I really have to divide the 9 off of this side to kill that. Perfectly legal as long as I do it to this side as well. So the absolute value of x plus 8 is less than or equal to 45 divided by 9 is 5. Okay, now I have the absolute value bars isolated. Now I'm ready to split to two inequalities. X plus 8 is less than or equal to 5, and x plus 8 is greater than or equal to negative 5. Now I have two inequalities. Solve them both. Both happen the same way. Subtract 8 from both sides here to find x is less than or equal to negative 3. Subtract 8 from both sides here to find x is greater than or equal to negative 13. These are my two solutions. Each of them has half the number line represented. Now I'm going to show them up on the number line to see whether they're conjoint or disjoint. I'm going to put my negative 13 about here and my negative 3 about here. X is less than or equal to negative 3, so solid dot and it's going this way. X is more than or equal to negative 13, so solid dot and it's going this way. In this case, what we have is what's called conjoint. The solution has to be somewhere between these 2 points. Now, there is a secret to seeing that. If you have a less than in your original inequality, and it doesn't have to divide by negative or anything, less than indicates it's going to be conjoint. It's an and. Greater than would indicate it's a disjoint. It's going to be pushing out in both directions. But the truth is, the easiest way to see what that is to just graph it and see what the solution winds up being. So there you go. Solving an absolute value equation gives you 2 answers. Solving an absolute value inequality gives you 2 answers as well, but half the number line, one direction or the other, from each of those 2 answers. You're going to split it once it's isolated into 2 equations or inequalities, and then you're going to solve each separately and graph them. Good luck.